it is a very important central concept to talk about the measure of central tendency, as if the data cloud, when we measure a lot of data, the and especially when the measurements, the numbers tend to repeat around certain numbers like 10, 10.1, 9.9, 9.8, 10.2, so it clouds around 10, for example. Then there is this idea about, is there the center of gravity? But we don't have gravity, right? So we borrow that center of gravity concept from physics, and we want to talk about where is that so-called one number that summarizes, that represents all the numbers, all the data cloud points. So it's a bit like physics where we say there's a lot of point masses, and where is that CG, right? Where's the center of gravity? And it's got very interesting characteristics where, because if it's the center of gravity, we put a pivot at that point and it will be able to balance the whole mass, no matter how odd shape it is on the left and the right? Because it is the center of gravity. And central tendency, if you think of it that way, has got that idea and even that behavior also. Yeah. So that is the whole point of uh, understanding or finding these measures of central tendency. When we say measures, it just means different ways of getting it, and different ways simply means different formulas of getting it. Yeah. How do we get the center of gravity? That means using different ways, we often end up getting different center of gravity, center of central tendency, right? What is central tendency? Think of that one number that summarizes all numbers. And that would basically bring out the characteristics, right? Then there are a lot of numbers. Can you just give me one number that's representative? Now, before we get into like the three different measures, um, is that a common thing? Why do we want to talk about central tendency? Now, you see, if you are asked to find out the heights of the classmates, let's say you have a 30 student class, right? 30 classmate class here. And the student, puts you in charge of finding the heights of the class. The teacher just says that, find the heights of the class. Oh, okay, fine. So you start measuring, right? And in order to be very accurate about things and not be seen as sloppy, you actually measure the heights of all your classmates, including yourself. So all 30 heights, all 30 numbers. Then you report to the teacher and says, well, the heights of the class is 1.51, 1.48, 1.62, 1.53. You're going to start narrating that. And before you even go on to the fifth height, teacher interrupts you and says, wait, this is not how I intended to be. Can you give me a summary? Right? Because that doesn't have to be a teacher student thing. You can be reporting to a teacher about the heights. You can be reporting to consumer spending to your boss. You can be reporting about physical fitness to your military commander. You could be, just reporting to another supervisor. And when you report, you don't really want to narrate the measurements. What if you have 3,200 measurements? What about working in e-commerce companies and they have hundreds of thousands, if not millions of transactions, right, at every server every day? How are you supposed to report? Are you going to narrate down every single transaction, the price, the delays, the transaction time, and all that? Well, it's not possible. So we always love to have some sort of a representative single number, right? Because it is giving some information. And if you want, we can give more, but unless you want, yeah. So how do we summarize measurements and numbers? That is exactly what measures of central tendency gives us. Give me that one center of gravity number, right? So the representative number. Okay, so I hope now you get the idea that this is very important to our daily communications. If without this, it's just chaotic, right? It's just unimaginable how we even try to communicate. So there are three acceptable ways to talk about central tendency, the representative. Now, why are these acceptable ways, first of all? The thing is there an unacceptable way? Of course, there are many unacceptable ways. Let's look at a bunch of numbers like this, right? So let's say this is measuring weight of apples or something. How many times did I see an apple weighing 30 grams, so tiny, so light? One apple, okay, probably rotten apple. How many times did I see an apple weighing 50 to 60 grams? Five of them, 60 to 69 grams, eight of them, and so on. Yeah. So we can then ask, well, okay, so tell me, how heavy are these apples? You can then say, well, one apple weighs 30, 50, five apples weighs 50 to 59 grams. You can read them out, but again, that's not very efficient nor meaningful communication to whoever you are talking to. Can be your customer as well, right? So how heavy are these apples? Implied expectation, one number. Now, what if you say, oh, these apples weigh 30 grams? Because you are using one number to summarize that, right? Of course, I know you're screaming. How can that be? This is like not representative. Why? Who says it's not representative? Yeah, of course, you understand why, right? Because it is not representative, right? It is like the least, and there's only one occurrence. How can we say that it's representative? That's very good. That's very fair. What if I say, dear customer, actually the apples very good. They all weigh, or rather the apples weigh 105 grams, or actually around 100 grams. That's a one number summary, efficient in communication, but a bit deceiving also, don't you think? Yeah, I'm sure you already said that. Yeah, so these are not good measures of central tendency. All right, we like central tendency because maybe we are built symmetrical, so we love things that are kind of balanced. You're neither underreporting nor overreporting. So there's got a lot, to go with how we go about doing business and how we ourselves are being created in the first place, right? So we love centrally placed um, situations, right? So be it balanced kind of pivot or a number that's pretty center. So then the question is, how do we find or calculate a number that's pretty center? And of course, I think everyone knows. Take the average of all the numbers. So now we are back to summation symbol, where we say add up all the apples weights and let capital N, and here when we use capital N, that just implies population. All right, when we use small n, we would mean a sample. So this is pretty international as well. So please don't mix and match, right? So we use capital N to imply population. Therefore, what is my capital X here representing? Is it a population or a sample? Well, from here, the context just implies that capital X is a random variable that is a population having n measurements, because capital N implies population. So some of these are telltale signs that will kind of spill over to define better what is the nature of this histogram. Is it population or sample? What's the nature of this random variable? Is it population or sample? All right, so here it just brings out this average idea, that is get the weights of x1, x2, x3, apple 1, apple 2, apple 3, all the way to apple capital N. Yeah, add them all up because it's a sum. That's why it's called summation, right? Add them all up and then divide by capital N number of weights, and that is just implementing average. And we all love average. We all admire average. When you report the average weight to your supervisor, boss, the average apples weigh 72.4 grams. Your boss is not going to scream at you and say, are you that accurate? How can you get zero point 0.4 grams? Well, you did mention average, right? And people understand that it's an average. It doesn't mean that an apple actually has to weigh 72.4, or all the apples weigh exactly 72.4. No one will think like that, right? Because it's quite well understood concept. And that is the reason why average is a very good summary measure of how we can efficiently summarize numbers.